Imagine you're driving home from work, or about to go on stage for a presentation, or maybe you're just having a social gathering with a couple of friends, when suddenly your body temperature spikes and it causes you to sweat profusely. You slowly get agitated with all the heat that's radiating from your body and you lose focus on what you were doing. This is the reality of what is experienced during menopausal hot flashes, which affects about 42 million women. With a few portable or inconspicuous devices that's out there, the team has focused on designing a system that is both continuously wearable and automatic to alleviate these symptoms.
The first component is a skin patch that is less than 5 square inches in area. It has adhesive strips on the sides and 2 electrodes in the center to measure the skin conductance on your chest. This is how the device will know you're having a hot flash. This information is relayed via a microcontroller to the second component, which is essentially a small box that can be worn as a necklace. The box has plastic mesh on 3 sides to allow for airflow and protect the user from the vibrating piezoelectric fan housed inside.
The first part of our device is a detection mechanism to tell whether or not a hot flash is occurring. We'll be looking for increases in skin conductance that are caused by sweating. The detection mechanism will address the automatic activation need of our device. The detection device measures increases in skin conductance which is caused by sweating. For testing, we moved electrodes from a plate with no solution to a plate with a solution that represents sweat on a user's body. This caused a hot flash to be detected. The detection device will then send signals to the cooling portion of the product.
A special feature of the FlashAway is that the cooling starts and stops automatically. The signals from the detection module are fed into a microcontroller. If a hot flash is detected, the microcontroller activates the cooling circuit. Here, DC power from a rechargeable battery is converted to AC power. This AC signal allows the piezo disc to vibrate so that the attached fan produces airflow. After 5 minutes, the cooling stops and detection starts again for future hot flashes. Thus, the user is cooled through the duration of the hot flash without having to start the device, stop it, or taking it off. All the user needs to do is put the device on at the beginning of the day and then just forget about it.
The team is trying to build a device that can detect a hot flash and initiate a cooling mechanism for 5 minutes to provide relief. The next steps in our design process include building the piezoelectric fan using simulations we have developed and conducting beta testing. Lastly, we would file a de novo request with the FDA since no predicate device exists. So beat it in a flash with FlashAway.